Hello everyone, welcome to my your programming club. Today we will be solving another daily lead code problem, and the problem's name is maximum total importance of roads. So the problem statement goes like this. You are given an integer n denoting the number of cities in a country. The cities are numbered from 0 to n minus 1. Okay. And you are also given a 2D integer array roads where each entry in the roads array denotes a bidirectional road between two cities A and B. Okay, so you need to assign each city an integer value from 1 to n, just like it is being done in this particular example. You can see the blue ones are 2, 4, 5, 1 and 3. Okay, so where each value can only be used once. Okay, so you cannot use these numbers from 1 to n for let's say you are wanting to use nth number for two cities, then this cannot happen. You can use that number only for one city, assigning it to one city. Okay, and then it is mentioned that importance of a road is then defined as the sum of the values of two cities it connects. Okay, so for example, let's take it to the board to understand it a little bit more clearly. Okay, so here if let's say we are focusing on the board 2 and 4, uh, on the road 2 and 4, then what is the sum of the values assigned to city 2 and 4? Okay, so because there is a connection between 2 and 4 because of this road indicated by red line, so the total of these two will be 5 plus 1 is equal to 6. Okay, so this is what the problem statement is saying here. So the importance will be 6 for this road. Importance of for the road connecting cities 2 and 4. Okay, so you have to return the maximum total importance of roads all roads possible after assigning the values optimally. So you have to assign the values of these integers to cities in such a way that the maximum total importance of all the roads happens to be maximum after assigning of these numbers. Okay, so if we take this example only and try to make some observations here, then we will be seeing one crucial observation, which is that whenever there is a city which is connected to more number of cities, it is assigned the larger value. For example, 2 was connected to, let's take a different color here. So here 2 was connected to a different three different cities. So its connection degree, you can say degree for 2 will be 3. So it was connected to number of cities connected to. Okay, so 3 cities it was connected to, so its degree was 3. Now similarly, if you look for 1, then 1 was also connected with 3 cities. Okay, and then if you look for 3, 3 is connected to 2 cities, and 0 is connected to only 2 cities, and then 4 is connected to only one city. Okay, so this is the number of cities each city is connected to. Okay, so now once we are having this kind of list with us, okay, so degree will be the number of cities a city is connected to. So this is the city number. Okay, so what we have done here is, if two cities are connected to the same number of cities, then you can assign either of these cities a higher number. But they like 2 and 1 were having the highest connections, which were 3. So either of them can have the highest number, which is 5, and the other one will have the second highest number. Okay, so things will go on like this. So we assigned, let's say, 5 to 2, or you can assign 5 to 1 also, because it was having the highest connection. Then we will be assigning 4. Then you can see 3 and 0 are having same number of cities, so you can assign 3 any number between 2 and 3. And okay, so let's say we assign 3. Then 2 was having again highest, so we assign 2. So you can see that numbers are starting from n and going up till 1. And fourth city, as you can see, the number of cities connected to it was 1, so it was assigned only 1. Okay, so this is the overall approach here. So we are only interested in seeing how many cities a particular city is connected with. Okay, so this is the whole logic for this particular problem, to solve this particular problem. And it will greedily give us the maximum total, what was the thing that was asked, maximum total importance. Okay, so in order to achieve maximum total importance, this is what we will do. And it is very then we can very easily, get the maximum total importance. How we will be getting it? So you can see here, number of cities 2 will be connected to was 3, and it was assigned 5. So this 5 number will be used for 3 cities. So it will be used, let's change the color here. So it will be used for this road, 5. 5 will be used for this road, and 5 will be used for this road also. Okay, so this road going up till 0. Okay, so you can very well multiply this and then have a addition of all these. Okay, so what I am saying here is 3 multiplied by 15 plus 3 into 4 plus 2 into 3 plus 2 into 2 plus 1 into 1. So this is what we will be doing here. So this is the number of cities a city is connected to and the number it is assigned. Okay, and this will be your result. Okay, so you can very well see that this will be the indeed will be the result. Okay, and if you do a total also, then it will come out to be exactly what we are requiring. Okay, so you can sum up this and it will be, you know exactly the number that we are wanting. Okay, so I think I have done some calculation mistake manually. So this will be the overall approach in nutshell. So it was not 15, it was 5. Okay, we have done a mistake here. 5 only. Okay. So I hope you are able to understand the overall approach. Now let's have a quick look at the implementation code also. Okay, so this is the code. It's a very concise code. So here what we will be doing here is, first of all, we will be having a degree array. It will be representing the number of cities a city is connected to. Okay, so number of cities a city is connected to. Okay, there is a logic here that why I'm, decrementing their degrees instead of incrementing. Basically, what happens in Java is, for default data types you cannot have a logic to sort, so it will always by default sort in, I guess, in ascending order. So in order to reverse that order, I have taken up negative values. So higher the negative value, the more chances will be for it to come to the front. So the array will be sorted like this. Okay. And once we are having the number of cities each city is connected to, then our work is very easy. We will be starting from assigning number from n, and we will be going up till 1. Okay. And we will then be adding it to the total importance. Before adding it to the total importance, since we have converted every number of cities, a city is connected to a negative number, we should be converting it to a positive number back. And then this 1l is for converting it into a long number. Okay, because a return type is long, and at last we will be returning this total importance. Okay, so this is the whole approach. And although we should be looking at the constraints before solving any kind of problem, but since we have used only linear time complexity here, it was not a major concern, but it is a good practice to have a look at the constraints before thinking of uh, an approach for a solution. So constraints were that the number of cities will be of order 10 raised to power 4, 5 into 10 raised to power 4. Same will be the length of the roads. Okay, roads array, and each entry in the roads will be of size 2, indicating two cities which there is a road. Okay, and it is mentioned that a city is never connected to itself. Okay, so there is a not a city for which a road is leading to itself. Okay, so there are no self loops, and there are no duplicate roads. It is mentioned. So these were the constraints. So what will be the time complexity for this one? Time complexity wise, as you must have guessed, it is order of n only, where n is the size of the this roads array. Okay, and space complexity wise, again it is n, order of n, because we are using this degree array. Actually, there is a little thing that I forgot to take into consideration, that we have sorted this array also. So instead of n, it will be n log n, because for sorting that much time complexity will be required. So n log of n will be the time complexity, and space complexity will remain same. Okay, so these are the complexities. If you are still having any kind of doubts or any queries in general, then you may ask them in the comment section. I hope this solution walkthrough added some value to your journey of honing your DSA skills, and I will see you in the next video. Until then, keep practicing more problems, and thank you for watching.